determining the molar mass by the Dumas method. What we have here is the setup, and we have a beaker of water that's here, and inside the beaker of water is a flask sitting inside the water, and inside the flask inside is 5 milliliters of an unknown volatile liquid, and on the top is a foil cap on the flask with a little pinhole in it. And the idea here is that we're going to heat up the water bath on this hot plate, and as this water surrounding the inner flask gets warm, the liquid, the unknown volatile liquid inside the flask will start to vaporize. And as it vaporizes, the pressure of the gas inside the flask will increase. And the outer pressure is atmospheric pressure, and we're going to assume that's 1 atmosphere for purposes of this demonstration. The 1 atmosphere is pushing down, and as the vapor gets warm, it will be pushing up, and its pressure will be greater than the atmosphere, and so the gas will start to come out, push out of that little pinhole. We call that a plume. And so what we're going to do is we're going to watch for that plume such that all of the vapor will escape until the pressure of that vapor inside is equal to the atmospheric pressure. At that point, no more vapor will escape and no air will come in. So the flask, the inner flask, for all practical purposes at that point, is filled just with gas of the unknown liquid. So then we're going to take this off. We will cool it down, and we will mass the gas inside because we already know the empty flask and the foil cap mass. We will also note the temperature at that point right before we take it out. So we will have the temperature, we will have the mass of the gas, we will have the atmospheric pressure, and we will have the gas constant R. And from that, we'll calculate the moles of gas that were in this flask. And we'll do that at the board. So now we're going to start it up, and then we will show you what's happening. Okay, so now the water is heating up, and the gas inside the flask, the unknown liquid, is vaporizing, and it's coming out of the pinhole. And you probably can't see that, but there is a line of vapor shooting out of that pinhole up here, and what I'm doing is watching that line of vapor come out. Now, what that means is that the gas pressure inside there is greater than the atmospheric pressure, and so it's pushing any excess gas out through that hole. And it's going to continue to do that, and I can still see that line of vapor. It's going to continue to do that until the gas pressure inside is equal to atmospheric pressure. At that point, the gas pressure inside is equal to 1 atmosphere. So I'm just going to let this thing continue to go until I don't see that line of vapor coming out anymore. And that will tell me that when the line of vapor isn't coming out, that the pressure is equal to the atmospheric pressure. Okay, I no longer see the vapor coming out, so I'm going to wait 2 more minutes just to make sure, and then we're going to cool it down. Okay, so we're going to note the temperature 99.8. So 99.8, we'll write that down. And now I'm going to take this off and cool it Now we're going to condense the hot gas inside there by running it under some cold water. And we'll do that for a little bit just to get the gas to condense. Trying not to get any on the foil. And now that the gas is cool and condensed, I'm going to dry it off. Dry off the flask thoroughly. And also going to dab the foil, taking it off the clamp here. And I'm going to dab the foil dry just in case there's any condensation on the foil. We don't want to be massing water, just the gas that's inside there. Okay, so now I'll take it over to the balance. It's dry and I'll mass the entire setup here. Okay, so we cooled the gas that was in the flask and we massed it. And now we took off the foil cap and filled up the flask with water because we want to get the volume that was available to the gas. And so if we fill up with water this flask, we can pour it into a graduated cylinder and we can determine the volume that was available to the gas that was inside the flask. And so when I read the volume on the graduated cylinder, it's 146 milliliters. 146 milliliters. So now we'll go to the board and we'll do a quick calculation.